I'm Anil Kumar. Welcome to my series on factoring polynomials. This video is especially for my student Ria, who wants to understand how to factor polynomials. So I've taken up around 18 questions here. There are 16 questions on factoring where we'll discuss different techniques, and then there are 2 thinking and application questions. Let us see one by one how to answer and understand this topic. Now you may have to practice some more questions to get more than 90% marks. However, it almost covers 90% of what you need to know, right? Some more formulas which you may require are like this, especially 2, which is difference of cube. If I have a cube minus b cube, in that case, to factor, we can write this as a minus b times a square plus ab plus b square, right? And if this is a cube plus b cube, in that case, you can factor this, the sign changes. It becomes a plus b times a square minus ab plus b square. Now this is a very important formula which some of you might skip, so I have made a note of this. And of course you know difference of square formula, which is a square minus b square can be factored as a minus b times a plus b, right? So that should help you to factor these polynomials. Let's begin with the very first question, which is to factor if possible. Now, it's important to note that sometimes it is not possible to factor, right? So that is why if possible is always written. However, in all my examples, I have taken up 2 which are unfactorable. Let me go back to this. Okay, so I have taken up 2 which are unfactorable, right? These 2. Now these are unfactorable, however, you need to factor them also, right? So check technique. Check method to factor unfactorable. Okay, so normally they cannot be factored, but now it's kind of completing the squares, okay? But some can be factored, especially of these kinds, x to the power of 4, right? So let's begin with the very first question. Now here we are given 4 terms, right? So in this case, when we have 4 terms, we can use the technique of group factoring, right? So here we'll use group factoring. As you can see, from the first 2 terms, we can take r common. So I could write this as r times p plus q. Now in the second group of 2 terms, we can take s common with a negative sign. So negative s, and we again get p plus q. Right? Now we have a common factor, p plus q. So we could write this as p plus q times r minus s. Is that correct? So that is how you do group factoring, right? So these examples are all related with group factoring, right? So here again you can apply the same technique. So in the first 2 terms we have x square common. So I'll write this as x square, and we have x plus 3. Now in the next 2 terms 2 is common, right? So we have 3 plus x. Now x plus 3 and 3 plus x is kind of same thing. You could go one more step here just to write it in proper order. That is commutative property, right? Okay, and now we'll factor this. Taking x plus 3 common, we get x squared plus 2. Now x squared plus 2 cannot be factored, right? X squared minus 4 can be factored. This is not difference of square. So that is complete factoring. Is that clear to you? C, 5yx minus 4 plus 3 times 4 minus x. Can you factor this? Do you have a common factor? Well, x minus 4 and 4 minus x, does that remind you of something? Well, what we could do is we could change the sign. See what happens. We get 5y times x minus 4. And if I take this sign as negative, right, then they become kind of reversed. We get minus 4 plus x, which is same as x minus 4. Do you see this? So let me rewrite this. Adding one more step, not really required, right? We could have gone direct like this, 3 times x minus 4, right? Now you can clearly see that x minus 4 is a common factor. So we'll write this as x minus 4 times 5y minus 3. Is that clear to you? That is how we are going to do it. So once again, you can now pause the video and do part D yourself and then check with my solution. Perfect. X cubed minus x plus 1. Now in this, what happens? If I take x square common in the first two terms, I get x minus 1. And here I can take minus common. So again, I get x minus 1. And so we can factor x minus 1 and we get x squared minus 1. Now x squared minus 1 is difference of square, correct? So that can be factored, right? That can be factored. So what do we get here? Well, we get here x minus 1 times difference of square could be written as x minus 1 times x plus 1. Do you see that? So that will be your factored form. Now some of you can also write this as x minus 1 whole square times x plus 1, right? So either one of these two as your final answer is the correct answer. If you leave this at this stage, right, this is incomplete. So whenever we are saying factor, then normally in the question it will be fully factored. So you have to actually write till the end, right, taking out all the common factors. That's kind of key to get full marks in this topic. Is that clear to you, right? Now let's take up other parts. Now here, factor if possible, we have now trinomials, right? So in trinomials, we use product and sum. Trinomials means 3 terms, right? And we use the method which is called product and sum. It really means that a times c, right? Coefficient of x squared and this gets multiplied. So we are looking for two numbers whose product, let's say two numbers are p and q, is 6 and whose sum is 5, right? So that is what we are looking for. So do we get something which could give us that kind of product and sum? Well, 3 times 2 is 6, right? So 3 times 2 is 6. When you add them, you get 5. And so I could write this directly as equal to x plus 3 times x plus 2. Is it clear to you? So it is a one-step process once you find product and sum, right? So these are fairly simple questions, but you should master this technique. Now the next one here is 6x squared minus 13x plus 6. This is also product and sum. However, in this we have one added step, and that step is we'll do product and sum plus decomposition. Correct? That is to say, once you find that combination of that magic number p and q, you need to decompose 13x, right? So in this case, we are looking for product and sum of 6 times 6, which is 36, right? And their sum should be minus 13. Now, what are these two numbers? Well, in this case, since their sum is minus 13, we could take minus 9 and minus 4. So we are going to decompose minus 13 into these two terms. So we get this equal to 6x squared minus 9x minus 4x. That makes it 13x, right? With a negative sign. Now that helps to factor. In the first two terms, we have 3 and x common. So we'll take 3x common. We're left with 2 times x minus 3 Here we can take minus 2 common and we get 2 times x minus 3. The sign changes when you take minus outside, right? So now 2 times x minus 3 is common and we are left with 3x minus 2. That is the factored form. So as you can see here, we kind of decomposed the center term, right? So that was related and written as two terms, one as minus 9x, the other as minus 4x. And then that helped us to find the solution. Is that clear to you? Correct? Now, in the third example, it's again a trinomial. We'll use product and sum, but there is a minor difference here. We can first do a group factor here, right? So the variations I'm writing here, so we could do a group factor. Now, you will think, what group factor? Well, it is the negative sign which we could factor, right? So we could take negative out, and once you do that, you get 9n squared minus 6n plus 1. Do you see that? Now, once you do that, you have this kind of a term, and this seems to be a perfect square, right? So then this technique we are combining with perfect square. Now, what is that perfect square thing? Well, I didn't give you this formula, but a plus b whole square can be written as a square plus 2ab plus b square, right? And if we have a negative term here, that is, if I have a minus b whole square, then this term is negative, a square minus 2ab plus b square, right? You all know this formula. Perfect. So that is what this perfect square is. You will notice that 9n square could be written as 3n whole square. This center term is minus 2 times 1 times 3n, and the last term here is 1 square. So a square minus 2ab plus b square, that means a minus b whole square, is the formula which I could apply. So using this formula, I can straight away write this as 3n, right? That is my first term, and the last term here is positive 1. However, in between we have negative, because that is negative 2 times ab. So it is 3n minus 1 whole square. So that is our final answer. Do you see that different technique used here? Okay, now here once again we have kind of a similar case. 3x squared minus 18x minus 81. We could factor 3 out, right? So if I factor 3 out, which is a common factor, I get x squared minus, that becomes 6x, and this is minus 27. Okay, now we can use product and sum. So these 4 examples are kind of different in so many ways, right? So now we could actually find product and sum. We are looking for two numbers whose product is minus 27 and whose sum is minus 6. Well, how do you get that? 9 times 3, right? And 9 being negative, 3 being positive. That should help us. So using product and sum and group factoring, we can factor this, and this can be written as x minus 9 times x plus 3. Does make sense to you? So we use product and sum here with group factoring. So here in this case we combine group factoring plus product and sum. So these are different techniques which you can apply to factor polynomials. It does make sense to you, right? Now let's move on and take the other questions. In this case we are going to apply difference of squares. The formula for difference of squares, as I've shared earlier, is a square minus b square can be written as a minus b times a plus b. Their orders can always be changed. Perfect. So that is the major formula which is going to be used in these 4 examples. I would like you to now pause the video, answer these questions, and then look into my suggestions. So I hope you got your solutions. Here is my suggestion. 49x square minus 64. 49 is 7 square, right? So we could actually treat this as 7x whole square. The other term is 8 square. So that is what we mean when we say difference of square, right? So A is 7x, B is 8 for you. And therefore, I could directly factor and write this as 7x minus 8 times 7x plus 8. Does it make sense to you? So that's so simple. Perfect. In the next example here, we don't see squares, but there is a common factor. So what we are going to do here is we are going to add different squares with common factors, right? So we'll do common factors first, correct? So common factor here, both are even numbers. We could write 2 as a common factor. We get 9x squared minus 4. Now, 9 is 3 square, right? So therefore, we could write this as 2 times 3x plus 2 times 3x minus 2. Does make sense to you, right? So what I did here was, see, we had this term, right? 9x square means 3x whole square, correct? And 4 is 2 square. So that is difference of squares. And so we could write this in the factored form using a formula for difference of squares. You see, it's kind of important to visualize this difference of square and then apply it. It's a very important application. Now here K and L are actually slightly difficult questions. Now here the technique will be that we have again 4 terms. So whenever you have 4 terms, in that case we'll definitely do group factoring, right? Now in this case, it is better to factor one group of trinomial. So group factor trinomial plus the difference of square. That should give you these solutions. So let us see how. So what we are going to do here is that we are considering the first 3 terms and the other terms separate. The reason being 4y square is 2y whole square, right? So, and the first 3 terms is a perfect square. You could write this as x plus 3 whole square. Do you see that? X square, and this is 3 square. The center term is 2 times 3, which is 6x. Perfect. So that is what it is. And here we have 4y square. As you can see, 4y is 2y, right? So 2y whole square, correct? So think like this. It is 2y whole square. Now, since it is difference of square, we could write this as x plus 3 plus 2y times x plus 3 minus 2y, correct? Now, this order can always be changed. It doesn't make sense to you. So these are slightly difficult. However, these are your test questions, right? So practice on these. Now, using this technique, which is similar, you need to factor the next one. Take this as your test problem. You can now pause the video, answer this question. Okay, now how will I do it? Well, this time we have y and y squared. So again, I'll make groups of 2 where 3 terms will be in one group. Do you see that? So I'll do like this. I will write this as x squared minus, and one group which is, I'm taking minus outside, so I'll change all the signs, correct? Now look here, this term is a perfect square, so it's a combination of difference of square and perfect square. So we get x squared minus, this term can be written as 7, right? And then minus y whole squared. Does it make sense to you? Now we have difference of square, and so I could write this as x negative sign now, right? Negative sign x minus 7. I'll change both these signs. Is that clear to you? Times x with a positive of both, which means the same signs. So that becomes your answer. Is that clear to you? Perfect. So what we saw in this particular case is a combination of difference of square after perfect square. Do you see that? So first you do perfect square and then you do difference of square. So that is another very important technique which you should understand to factor polynomials. Correct? Now we are into difference of cubes and sum of cubes. So we have two examples here. So let me once again give you the formula. If I have difference of cubes, that is a cube minus b cube, it could be factored and written as a minus b times a square plus ab plus b square. But if I have sum of cubes, that means the formula will be what? Sum of cubes can be written as equal to a plus b times, so the sign changes, right? So we have a square minus ab plus b square. Is that clear? Use this formula, factor, and then check with my solution. Simple as that. So what we are looking at, this is like x cube minus 2 cube. Do you see that? So a is x, b is 2. We could factor this and write this as x minus 2 times square of x plus product of these two, which is plus 2x, time plus 2 times 2 or 2 square, which is 4. So that is how you're going to write it. The next one here, which is 2x cube plus 54. Now here, first we'll factor 2, which is a common factor. Now we get x cube plus 54 divided by 2 is 27. Now 27 is 3 cube, right? So we can again apply the factoring technique of sum of cubes, correct? So we get here x plus 3 times square of x, product of these two, which is plus 3x, sorry, minus, right? Minus 3x minus plus square of 3, which is 9. So that is what we get. Perfect. So the two techniques which we used were, here we use sum difference of cube, right? So let me write sum or difference of cubes. And in this case, we added with group factoring, right? So first you group factor followed by the sum of cubes. Perfect. So these are different combinations which are applied to factor polynomials. Now here we have two examples. Now these are very interesting examples. As such, if you apply product and sum, two numbers which can give you a product of 1 is 1 and 1, but their sum or difference, it cannot be minus 3. And therefore, it is unfactorable, correct? So it is unfactorable. Similarly, this example 36, any two numbers when multiplied, like 4 times 9, 12 times 3 or 36 times 1 will never give you 3 as their sum, and therefore this is also unfactorable. However, we have a technique which helps us to factor. It's kind of a extension of completing squares. So that is what we are going to do now. So what we do here is we look for a perfect square. So we could write this as x to the power of 4. Now the term is 1 here. So what is a perfect square kind of a thing? Think like this. When I say a minus b, since there is negative here, I'm just using a minus b whole square, is basically a square minus 2ab plus b square, right? So in our case, we have 1 as b. We have x square here, but the center term is not 2x square, right? But it is minus 3x square. We need minus 2x square. So what I could do here is I could split this and write this as minus 2x square, correct? Minus x square plus 1. Do you see that? So by rearranging, I could now write this as minus 2 square plus 1, and I'm taking this separate, minus x square. Now what you notice here is that these three terms become a perfect square. And therefore, I could now write this as x squared minus 1 whole square. So that will give you x to the power of 4 minus 2x squared plus 1. And here we have minus x squared. Do you see that? Correct? So here we have minus x squared. Now we can do the combination of this. A plus b times a minus b, right? So we could write this as a plus b, which is x squared minus 1 plus x, right, times x squared minus 1 minus x. So we have finally factored the unfactorable. Do you see that part? So it's very interesting and useful. And we actually decomposed the center term. So we applied here additional step of decomposition, right? And then we applied the technique of completing the squares. Now let's take the next one, which is a variation of the same. We have 36 here, right? 36 is, think like this. 36 is 6 square, right? Now, what do you need here? We need 2 times 6. We need here plus 2 times 6 is 12. We need here 12x squared. And this is x squared whole square. If I get that 12x squared, then I could actually complete the squares, right? But what do I have? I have 3x squared, not 12x squared. So to get 12, what should I do? I should add and subtract 9. Do you see that? So what you should do here is you should add and subtract 9x squared, right? So if I add and subtract 9x squared, I get the needful. Do you see that? So that is the thinking part. Think like this. It is not a step, it's just a thinking part, okay? It's incomplete. So the technique follows. So what I'm going to do here is, I'm going to write this as x to the power of 4 plus, we want 12x squared, right? So we already have 3x squared. We are going to add 9x squared, okay? So we're going to add 9x squared and subtract 9x squared. Do you see this? To make it 12. So we get x to the power of 4 plus 9 plus 3 is 12, 12x squared. We'll keep this 9x squared separate. So doing this, we have formed a perfect square. Correct? Now, we'll combine these three terms and they can be written as x squared plus 6 whole square. We have a perfect square here also, which is 9x squared, which is 3x whole square. Now this can be factored and we could write this as x squared plus 6 minus 3x times x squared plus 6 plus 3x. Does make sense? It is better to write them in proper order, so I'll change the order this time. It should become x squared minus 3x plus 6 times x squared plus 3x plus 6. So that becomes the factored form of the unfactorable trinomial. Do you appreciate it? Perfect. So if you want, here also we could write this in proper order and write this as x squared plus x minus 1 times x squared minus x minus 1. Is that clear? So with this, we have done the factoring part, and now let's get into some thinking questions. So this time the question is, show that 2 to the power of 9 minus 1 is a composite number. Now, so that means basically composite numbers means what? Means that they have factors. Composite numbers have, that means have factors. Correct? So let's see. Now 2 to the power of 9 minus 1. I could write this as 2 cube whole cube minus 1, right? So 3 times 3 is 9. So that is what it is. And now I can apply the formula of a cube minus b cube. So we have a minus b times a square plus ab plus b square, right? So what do we get here? So we can factor this. A is 2 to the power of 3 for us. So we get 2 to the power of 3 minus 1 as the first factor, a minus b. The other factor, square of this will be 2 to the power of 6 plus ab means 2 to the power of 3 plus b square, which is 1. Is that okay? So that is how you could factor this. Do you get an idea, right? So we actually factored it. Since we factored, we know it is a composite number. Is that clear to you? You could further factor. It is 2 cube, a cube minus b, all this. And see, interesting thing is that we could write this in this form also. 2 cube minus 1, and 1 could be written as 2 to the power of 0. 2 to the power of 6 plus 2 to the power of 3 plus 2 to the power of 0, right? So sometimes that is a part of your solution in a multiple choice question, right? Well, here we have a cube minus b cube. I'll further use this formula to factor it, right? So a cube minus b cube, so we get 2 minus 1, right, times square of 2, which is plus 2. Oh, sorry, plus 1, right? So this is the first term, and the next term here is 2 to the power of 6 plus 2 cube plus 1. Is that clear to you? Correct? So what do we find here? Well, there are a couple of factors here. 2 minus 1 is 1, right? And here we get 4 plus 2 minus 1, which is 6 and 1, 7. 2 cube minus 1 is 7, right? And this number is slightly bigger, which we are not calculating. Anyway, you could calculate. Now, to calculate these numbers, let me give you some good reference. 2 to the power of 10 is 1024. Is that clear to you? So that should help you to figure this out, right? You know this is 8, and that is 8 square, which is 64. So you could actually write this as 7 times. This is 64 plus 8 plus 1. Is it clear to you? And then you can add this, and we get 7 times 9 plus 64 is 73. So we get 7 times 73, and so we know that this is a composite number. But well, if you could factor, that means we have two numbers. Does it make sense to you? Separately, if the other number is not 1, correct? And therefore, we could write this as that 2 to the power of 9 minus 1 is basically equals to 7 times 73. Since it is product of two numbers, it is a composite number. Is that clear to you, right? So that is how we can do this interesting question number 2. Perfect. So now we have almost come to the end. Let us look into the last question, question number 3. Show that the function f of x equals to 2n cubed plus n squared plus 4n plus 2 produces a number divisible by an odd number for any natural number n. So here I've done some correction. Earlier we wrote a wrong question here. So produces a number divisible by an odd number. That is kind of important to understand, right? Now how do we show that? Well, for that, we need to factor our function and see if we get odd number, right? So we given the function f of x as equals to 2n cubed plus n squared plus 4n plus 2. We can do the group factoring, combining the first two. We have n squared common here. We get 2n plus 1. In the second group, 2 is common, so we get 2n plus 1 again. 2n plus 1 is a common factor, so we can factor this out. That results into 2n plus 1 times n squared plus 2. Now, as you can see here, one of the factor is 2n plus 1. Now, 2n plus 1 for n belonging to natural numbers, 2n plus 1 is always an odd number, right? Correct? And therefore, the function is product of odd times some other number, right? And therefore we can say that it produces a number. So we have a number divisible by an odd number. Is that clear to you? Perfect. So that is how we could do it. Now that brings us to the end of this beautiful series, and I hope with this your concepts about factoring are absolutely clear. Once again, the stress is you need to practice more to get more than 90% marks. This is good enough for 80 plus. Now here's a change in this question. So produces a number divisible by an odd number. That is kind of important. So we found that 2n plus 1 was a factor and 2n plus 1 is an odd number. So therefore the whole function, whatever number it gives, will be divisible by an odd number. Perfect. So I hope you understood all the concepts, especially the steps where we used completing the squares to factor unfactorable, right? So we did technique to factor unfactorable. Now that is very important and critical for bonus question or thinking questions sometimes asked. So I'd like you to go through these once again, understand all the concepts, and I'll provide you with a link so that you could do factoring with higher powers, right? So one thing which is missing here is factor higher powers. Okay, so for that I'm going to provide you with a link. Practice, and I hope you get good marks. Thanks for your time and all the best.